Hello and welcome to Building on Top of AWS Services for live and meeting experiences. We're joined by an amazing panel today to talk about the work that Zoom and AWS have been doing together. So to introduce the team that's going to be presenting, my name is Brendan Ittelson. I'm the CTO here at Zoom.
Hello, my name is Kinesis Judy, and I'm a Principal Solutions Architect with AWS, focusing on ISV and software as a service companies.
And hey, everyone. My name is Chris Lott. I'm a Senior Solutions Architect at AWS, focused on language AI services.
Thank you, team. So to kick things off, I want to talk a little bit about the partnership that Zoom has had with AWS. Zoom has had a long collaborative relationship with AWS. Our cloud-based platform incorporates more than 40 different AWS offerings, including compute, storage, and encryption solutions. Therefore, when we heard the challenge our developer community was facing, we saw an opportunity to optimize and simplify streaming participant audio and video to AWS AI, ML, and analytics services. As a result, developers will be able to provide richer in-meeting experience. It's been an exciting journey, and I'm excited for Sina to dive in.
Thanks, Brendan. Developers are excited to build next-generation communications and business productivity solutions with Zoom platform. Over the past year working together, we have come across a number of use cases that we can accelerate development and time to market for the developer community. There are many opportunities for startup, enterprise, and public sector developers to build agent assist, live translation, visual content moderation, identity verification, and other AI-based productivity apps. Today, we will talk about how Zoom and AWS teams are making this journey easier for developers. You will learn how to stream Zoom meeting participant audio and video live to AWS. We'll give you an example of the type of AI solution that you can build using this sample and architecture that we'll present. I want to start with a story about one of these use cases a year ago. AWS solution architects, Envision Engineering, and Zoom team collaborated on a live speech translation prototype. Live speech prototype involved having a speaker join a meeting and speak in a default language, let's say English, and for other participants to be able to listen to that speech in a different language. In this case, we used Mandarin. The architecture was simple. We piped mixed audio from a Zoom client to Amazon Transcribe for live transcription. We send that text to Amazon Translate, receive the translation from many of the supported languages, and convert text back to speech using Amazon Polly. Polly is powered by the same technology as Alexa, itself supporting many languages and voices. And the results were impressive. You could listen into a virtual translator live in Mandarin while the original speaker spoke English with about 1 to 3 seconds delay. But no journey is without its challenges, and we noticed this most when we were discussing operationalization. You see, packaging a desktop app to run as an executable in the cloud is virtually impractical. For one, manual interaction with the UI is not possible. And even if you run the applications in a headless, orchestrating a fleet of virtual participants running a desktop app is inefficient and cumbersome. And finally, most use cases we considered required access to per participant audio, not the mixed audio captured by the audio driver. As we dove deeper, we recognized the need for joint investment if we wanted developers to be successful. So in addition to operating the virtual participant at scale, we also faced the complexity of point-to-point integration with AWS and third-party services that provide that AI capability. These were ultimately going to be applications that consume live audio or video from a Zoom meeting and to provide value to the end users and end customers. Working with customers and developers, we knew there was a better way. And so we set ourselves up for the challenge with Zoom to create a serverless architecture and a reference solution on AWS. We kept 3 goals in mind to really help developers. First was removing as much friction as possible for you as developers so you can get products shipped to market as fast as possible. Next was ease of operation. It doesn't matter how fast you can build. If you can't run it and maintain it at scale, you can't really deliver value to your customers. And last was cost efficiency. We were conscious of the feedback from the developer community on this. And if the solution was not going to be economical, it will never see the light of day. We believe this architecture and reference solution can set you on your way to build great Zoom applications and successfully run them on AWS. We're so excited to share how you can get access. And for that, I'll pass it to Brendan.
Thank you, Sina. So I am also excited about this access to the reference architecture. And we will be releasing this as a solution that is open source on GitHub soon. Now, for individuals that are interested in this, we have a QR code on the screen now that you can scan to sign up and express your interest so that you can get immediately notified when that beta becomes available and to start use the reference architecture that we are discussing today. Now, this is coming out soon, but really it has been a journey to get to this point. So I'd love to talk about how we got here. So this comes really at the foundational step. At Zoom, when we initially designed this SDK, it was designed to build clients so that folks that wanted to customize a desktop or mobile experience could use it to build an end user experience. But as we worked with our developer community, we started to hear people that were looking at different use cases and being able to use our SDK to build different forms of automation or services. However, that was a challenge for them initially, especially for something that was designed for end users. I remember hearing early stories of people having rows of computers on benches and trying different ways of how can they orchestrate and automate and scale these solutions and having them work together. So hearing that, naturally, we talked to our friends at AWS and looked at how can we build something that can accomplish this together. And there were basically 3 steps to this process. The first area that we focused on was looking at how do we really make it easy to wire this SDK where it could be integrated and connected to other services, looking at really what are the fundamental parts and structures that we need to make available in interfaces for the proper exchange of data. And to get into details of how we did this and how it's leveraged, I'd love to turn it back to Sina.
Great. We collaborated on a number of areas within the Zoom SDK sample as a part of the virtual participant framework to remove some of that undifferentiated heavy lifting. And let's be clear, this is not a Zoom client application that's running. It's actually using the SDK itself so that we have programmatic access to the audio and video and the events that are happening within the SDK so that we can build these integrations. The first step, as Brendan hinted at, was repurposing the Zoom Meeting SDK for Windows to be the basis of our virtual participant framework. This was important because it gave the developers access to that high quality per participant audio and video using programmatic callbacks. Contrast this with capturing multimedia using the audio driver and screen capture when running a Zoom desktop meeting, and that's clearly not the better experience. And the thing that we did first was we wanted to create an easy way to send raw audio and video to AWS. For this, we have created a reference implementation using the GStreamer library that integrates with Zoom Meeting SDK for Windows and AWS and Amazon Kinesis Video Stream. We will touch on the details of the Amazon Kinesis Video Stream service and its SDK later in this talk. The second, we had to make an application headless so that it doesn't depend on manual UI intervention to join and leave meetings. And for this, we used a microweb framework for C++ called CroCPP and exposed HTTP join, leave, and health web endpoints on port 3000. We also used a JWT a JOT library for Zoom SDK authentication and a number of other utility libraries, again, to remove as much of the undifferentiated heavy lifting from your development. And lastly, we incorporated the Amazon Simple Notification Service SDK for signaling to consumers and also to let the fleet orchestrator know when virtual participants are in meeting or when they're free to join another one. In all, this allowed us to run a live data plane between Zoom Meeting and AWS as a virtual participant. Looking back at our design goals of agility, better operation, and cost efficiency, I want to recap 3 key considerations for you. 1, we want you to use this Zoom SDK sample solution to connect meetings with AWS. This will actually remove a lot of the trial and errors that we completed, and you can build much faster. 2, we want you to rely on these web endpoints for interacting with the virtual participant and the Amazon SNS notification for signaling. And lastly, to minimize development time, use the utilities provided in the Zoom platform and the AWS SDKs. You may wish to edit these and modify them, but they should be a really good basis for you to get started and get things done. Next, Brendan will touch on how you can scale your virtual participants in the cloud.
Thank you, Sina. So naturally, with the connections in place, the natural progression was, how do we scale these services? How do we allow people to take it from a single instance to actually multiple instances? Because as developers were successful, they wanted to be able to run and participate in multiple meetings in multiple sessions to help support their customers. Now, short of banks and banks of computers and trying to automate how to stand them up and provision them, that wasn't very scalable. So we were looking at how could we have a solution that really made it a better way to orchestrate all those systems coming online, having this SDK available, and being able to do that. So really, how did we take the single desktop app and make it really a fleet of applications? Now, AWS and Zoom have run workloads at hyperscale. We have a history of this. So once again, we borrowed our joint experience to make this easier for developers. So Sina, do you want to dive in a little more on what we did together?
Yeah, I'm glad to. So modern DevOps has provided a great way to run custom applications that scale in the cloud. Containerization has become a standard practice to create reproducible artifacts that run the same way in development, pre-production, and production environment. So we took it on ourselves to package the Zoom SDK sample and all of its dependencies as a Docker image. Now you can run them on your local desktop and in the cloud, knowing that it will run with the same business logic. Here are some of the AWS services that will actually help you run these containerized workloads at scale in the cloud. And the first step is, as I mentioned, packaging the SDK as a Docker image. And there's plenty of ways that you can do that, but we've actually provided the prescriptive way in our solution sample that will be released in a few weeks. Once you have that Docker image, you have to register it with a Docker registry, and for that we have Amazon Elastic Container Registry that provides that functionality. Once the Docker images are registered, now you can use Amazon Elastic Container Service to schedule them and orchestrate them on top of AWS Fargate. And AWS Fargate is a serverless compute for running containerized applications. Instead of you managing your virtual machines and patching and operating systems, Fargate will help you right-size the environment and the compute so that you're essentially just launching containers, and the rest of that undifferentiated heavy lifting again is taken care of by Fargate. And finally, once you want to actually auto-scale this, CloudWatch and CloudWatch metrics can be used as an input to that AWS auto-scaling. So if you have, during some times of the day, multiple virtual participants at scale, you can ask that fleet orchestrator to increase the number of containers that are available to join meetings. And when during certain times of day you may not have as many, you can actually auto scale down and save on costs on running these virtual participants. So again, back to our key design considerations, you can now run the same reproducible container image in dev, in prod, in any form of in-between environments, and you don't have to modify your code or dependencies to make that run and function. You can essentially create it once and run it in multiple environments. You can also operate this virtual participants with auto-scaling and familiar DevOps practices. I'm sure this is something that is much more pleasant than orchestrating custom software on top of fleets of machines on your own. And finally, to optimize resources for performance and cost efficiency, you can use the auto-scaling capabilities that are available to you in AWS to run these workloads very similar to how you run your other backend software. And now I pass it to Brendan to present the need for a standard data plane between Zoom Meeting and AWS services.
Thanks, Sina. So that takes us to the third step, which now that we had the interfaces and we could scale them, we wanted to really have a standard that could interoperate across the services. Because by having that standardized data plane, folks could interface across the various services to build solutions together. And our goal is really to look at how do we remove the barriers of entry. And so using this and looking at the data plane, we're able to not have it be a point solution in the cloud, but really look at an integration that reduces the learning curve. And in this case, the breadth and depth of the service availability in the cloud is no longer a challenge because there is a single interface that can start to span across. We took to ourselves to simplify the integration for you. And Sina can dive in about what Amazon Kinesis video stream and how you can quickly use that to build AI, ML applications leveraging this SDK.
Let's talk about this standard protocol for transmitting live media from a Zoom meeting, and ideally with developers writing as little C++ on Windows as possible. Amazon Kinesis Video Stream is a multimedia data ingestion, integration, and storage service on AWS. It's serverless and belongs to the AWS IoT services portfolio. You can use it to ingest audio, video data, or a combination of both, or really any data stream that requires timestamps and real-time ingestion. Underneath the hood, Kinesis Video Stream uses the Matroska multimedia container to package audio and video frames as fragments before transmission. The GStreamer library that I mentioned earlier helps capture audio and video from the Zoom SDK callbacks and send that multimedia data fragments to the cloud using the Amazon Kinesis Video Stream service. Here's the same diagram as Brendan had just shown, but with the producer and consumer of the live media data completely decoupled. In this case, Amazon Kinesis Video Stream acts as the standard data streaming protocol for multimedia ingestion from Zoom meetings to the cloud. And on the consumer side, AWS Lambda functions can be invoked to parse and integrate with AWS AI ML services or any third-party APIs. One of the key advantages here is that now you can actually build this integration in the language of your choice. Whatever runs on Lambda, you can run that and in the operating system that it allows, and also using the compute that's optimized for your workload. Let's do a quick walkthrough of this simplified data flow. First, a developer has to set up the framework, which includes the Zoom Meeting SDK app and the live media ingestion pipeline. Then the Zoom app sends data to KVS service via the KVS Producer SDK. And Lambda on the other side is parsing that data fragments and sending the data downstream to AI ML services by AWS or third party. For the beta, we've implemented an end-to-end solution that passes audio from Zoom Meeting to Amazon Transcribe for real-time speech transcription. However, in the future, we will make more integrations available, and we're really looking forward to the community to contribute to our open source solutions as you're building more and more integrations within AWS with third parties and building these all on AWS. Let's do again a quick recap of these design considerations that we've followed for you to build integration and downstream AI applications easier. First, you can build and integrate faster with the flexible choice of programming languages, as I mentioned. Most of these might be in Python, in Node, or really any language that Lambda supports. Leveraging existing AI/ML reference solutions built by AWS dev community is another big advantage, because as you can imagine, Kinesis Video Stream has been out for a while, and some of these applications have been built already for it. So now you can actually have Zoom act as a data source and leverage the same solutions that you've already built or other developers have built and shared with the community. You can reduce the operation and maintenance toil with serverless architecture, as we talked about, and auto-scaling based on load with pay-as-you-go pricing can act as a cost-saving mechanism for you. Now, let's get to the demo, and I'm really excited about the first one. This is a recording of a Zoom meeting that was transcribed using the framework that we've just described. The Zoom SDK sample application streams participant audio to Amazon KVS, and the consumer, in this case, is about 600 lines of JavaScript code, mostly done by Chris and his team at AWS, that reads the audio data from the KVS and transcribes it using Amazon Transcribe. A particular highlight in this demo is showing that the same SDK application and logic running on a standard Windows machine, representing my local development environment, and also running it as a Windows container with Amazon ECS on AWS Fargate, representing a production environment. That shows that duality, that the same code and the same logic can essentially run regardless of the environment. This is important, as it's the very reason why Docker and containers have gained so much popularity with the developers and the DevOps practitioners. Great. In this first demo, what I'd like to show you is a dual environment, one in my development and one in production, showing you how you can run the virtual participant framework both in your local environment, but also as deployed as a container using ECS Fargate and being able to invoke it via a Lambda function. So on the right hand side, this is my Windows environment. I have a local setup that will call the meeting, and I have a debug log showing so that it actually shows the recording of the meeting and sending it to Kinesis video stream. On the left side, this is the Lambda function. It effectively emulates the same. It emulates the same function as a curl. It's just sending the join and leave requests. At the bottom, you can see who's joining. So in this particular demo meeting, I have Chris and myself are the participants now. And on the right corner, these are the consumers that I'll run once the recording to the cloud and to Kinesis video stream starts. So with that, first, I want to show you the containerized version of this application running on ECS Fargate. So this is join. It's going to hit a base URL that the container is running on. And as soon as I send join with the right parameters, it should join as a Fargate virtual participant. So you can see that's the Fargate Zoomtopia. And at the same time, I can also have the local environment join as a second virtual participant. So this one should show up as a local virtual participant. So we have both virtual participants joining the same meeting. And now if I'm going to mute my local participant. If I start local recording using the host commands that I have, it should start sending the raw audio that's being captured from each user, both Chris and I, to Kinesis video stream. And I should be able to run two consumers that can show you the transcriptions that's coming from those Kinesis video streams. So with that, I'm going to allow local recording. This debug log will start streaming video out. And if I start my consumers, both Chris and I should be able to have our audio transcribed. So Chris, if you don't mind, maybe give me a couple of voice checks. 1, 2, 3.
Yep, testing. My name is Chris.
Fantastic. So Chris is on the left and I'm on the right. One other thing that I want to show, and you can see the call transcript is now showing up on the right side, is I want to give your attention that this call is actually having the personal identifiable information redacted. So if I ask Chris to give me his a random social security number, it should show it as a bracket SSN once the partial results are complete. So Chris, give me a social security number.
Yep, my social security number is 555-112234.
So what you can see is the partial results include the numbers, but once the transcription API gives the final result, it shows up as SSN, which is redacted path. So whether you send this to DynamoDB or downstream processing, the actual transcription that goes has this personal identifiable information redacted. So with that, I'm going to end the meeting. So again, I'll send the leave request to the local environment, and I can do the same thing with my Fargate task, and that should also have the Fargate one remove the meeting too. So with that, this demo is complete. We're going to show you a much more sophisticated version of this demo when we talk about log call analytics.
Thanks, Sina. Now let's talk about real-time call analytics and Agent Assist, part of the AWS Contact Center Intelligence solutions. These solutions improve customer experience, boost agent productivity, and lower costs. The demo recording we're about to show is based on Live Call Analytics Sample Project, which is an open source project designed to get customers up and running quickly with analytics and artificial intelligence for meetings in real time. Its source code is available on GitHub and is quickly deployable in a few clicks with a CloudFormation template. Out of the box, it includes a customizable React web user interface that will display transcriptions, show agent assist responses, and meeting summaries, all live while the meeting is happening. Agents can log into the web user interface and see agent assist suggested responses, and supervisors can see how the calls are progressing. Live Call Analytics deploys the entire infrastructure to help you get going quickly without writing any code. Now let's see a demo of where Sina and I join a Zoom meeting, and Live Call Analytics provides transcriptions and agent assist suggested responses. Sina is going to play the caller, and I'm going to play a call center agent. Pay close attention to the agent assist messages, highlighted with a teal background. These suggested responses are for the agent to read. Agent Assist will also look up an account balance and make a payment over the phone, all on behalf of the agent, based on what the caller or Sina is saying. Let's watch it now. Hello, thank you for calling Acme Bank. My name is Chris. How can I help you today?
Hi, I'm calling about my rewards card.
Excellent. Give me a second to look up your customer account. For verification purposes, can you please state your first name?
My first name is Sina.
One moment while we verify that the name matches our records. Perfect. Hi, Sina. How can I help you with your rewards card?
I was wondering, what is the cashback rate for this card?
I'm looking that up for you now. It won't take long. I see here that the rewards card has a 2% cashback rate on your everyday spending. Is there anything else I can help you with today?
Thanks, yes. Can I pay my card bill now while I'm on the phone?
Absolutely. We can process your payment over the phone. Give me a second to set that up. Can you please confirm the last 4 digits of your card number?
Yes, it's 1234.
Got it. 1234. So I can confirm that the card balance is $75.34. How much do you want to pay? There is a $50 minimum payment.
Yeah, I'll pay $50.
Okay, I'm entering a payment of $50. Do you want to pay from your checking account or your savings account?
My checking account.
Perfect. Your checking account. One moment, please. Great. So I've processed your payment of $50 from your checking account. Is there anything else I can help you with?
Nothing else just now. You've been a big help. Thank you so much.
No problem. I'm very glad to hear you say that. Well, thanks, Sina. We appreciate your business. Check out our website at acmebank.com to learn about all our other products, and feel free to call back if you have any additional questions. Have a great day.
Thanks. Bye.
Goodbye. The Live Call Analytics demo you just saw is powered by AWS's Language AI services. Utilizing the Zoom Participant Framework and the Language AI services unlocks powerful capabilities, which we call Contact Center Intelligence, or CCI for short. We can use Amazon Transcribe to do real-time speech transcriptions, Amazon Comprehend for natural language processing, Amazon Kendra for intelligent search. We use Amazon Lex for conversational AI and agent assist, Amazon Poly to synthesize text-to-speech, and finally, Amazon Translate, our award-winning language translation services. All of these capabilities are available to you without having to manage any servers or infrastructure. Simply start using the APIs. We provide SDKs in many different languages for you to get started quickly. Now let's dive a little deeper into the architecture for live call analytics. It is designed around two main components that I've circled: the Zoom meeting, including the virtual participant framework on the left, and the language AI services, starting with Amazon Transcribe on the right. Agent Assist can also see the real-time messages coming through on the agent portal on the bottom left. The architecture flow starts with the virtual participant sending the meeting data to Kinesis video streams, as Sina demonstrated earlier. From here, an AWS Lambda function ingests the KVS data, parsing out the audio and sending the audio to Amazon Transcribe. Transcribe will return the transcriptions in real time to the Lambda function, and we use the other language AI services to generate the Agent Assist responses. Finally, the Agent Assist responses, as well as the transcripts, are delivered via AWS AppSync to the web portal and are also persisted to DynamoDB. All of this happens in real time as the meeting is progressing. This entire infrastructure is open source and is available on GitHub to you and deploys quickly with the CloudFormation template. You can learn more about live call analytics and the other CCI solutions at https://go.aws/CCI. Sina, back to you.
Thanks, Chris. I am so glad we were able to share the solution with you today, and I can't wait for you to try it. Let's look back at what we've accomplished. We set out to help you build AI/ML solutions with the Zoom platform on top of AWS by making you productive, ease your operation burden, and at the same time, try and lower your costs. The LC architecture we presented was only a few weeks of work to integrate with the Zoom for us, and we think you can do the same. And that is sort of our goal, is to engage with you and work with you and help you build, but also try to give back to the developer community by making this open source and something that you can build solutions on top of. This has been a wonderful partnership, Brendan, and we thank the Zoom team for their tireless efforts helping us serve our joint developer community.
Well, Sina, thank you, Chris, and the entire AWS team. It really has been an amazing partnership, and I am super excited about what our developer community is going to be able to build with this reference architecture. I once again encourage anyone that is attending today that is interested in getting access to this architecture to please sign up now to get notified as soon as that open source reference architecture is available. It's a click away, and as soon as it's published online, you will get notified about it. We are super excited. We have seen what developers have built already, and knowing what this reference architecture will enable developers to do, we are so excited and inspired about what ideas will come from this and what new business opportunities and concepts will come to market. So we're very excited. This has been a great partnership. I'm excited for the future, and I really want to thank everyone who took the time to attend today's session. We look forward to see what everyone does as developers, and thank you so much.